welcome back to another video in this multi-course trigonometric explanation series, where in this video we're going to be explaining the 6 respective trigonometric functions, the graphs of them, which are sine of theta, cosine of theta, tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. We're going to start off this lesson today with the graph of sine. With the x-axis being inputs of the theta angle, and the y-axis being the result for each angle that we will plug into sine. We know from our special angles table that we have 4 special angles that we're going to be using. Well, we have many others, but for the sake of simplicity in this video, and for the sake of graphing, we're going to be using 4 specific angles. Special angles, that is, in sine. These 4 special angles are sine of 0, sine of pi over 2, sine of 3 pi over 2, and sine of 2 pi, which once converted back to degrees is 0 degrees, 90 degrees, 270 degrees, and 360 degrees. Well, how do we graph these angles onto the theta axis? Well, pi over 3, or so on, in angles in terms of radians, they're just in terms of real numbers, because we know that the pi value as 3.14, or this should be an estimate value, about 3.14. So we plug this into our radian values, which is like, for example, pi over 6. Well, to graph pi over 6 on the axis will be 3.14 over 6. And that's an estimate, that is. And we'll divide this out, and whatever value that comes out to, we plot accordingly on the graph. So with that background out the way, we can begin graphing out the 4 respective special angles. And as mentioned earlier, there's 0 degrees, 90 degrees, 270 degrees, and 360 degrees. So pi over 2 will somewhere be about here. Let's say it's here. Note, pi over 2 is about 1.07. So we can say it's about here, a little greater than 1. Along with pi, 3.14, we can say it's somewhere here. 3 pi over 2. 3 pi over 2. And 2 pi. We know from our special angles that the greatest and least possible greatest values for sine are 1 and negative 1. So that means the range of the sine function has to be 1, because it cannot exceed 1, or it cannot be lower than negative 1. So this leads to our range, the range of the sine function. But the sine function, note, is just sine of theta. We don't have any constants before the theta, and we do not have any amplifiers before the sine. So this is just sine of theta. 1 times sine of theta, parentheses, 1 times theta. In this case, the range, as mentioned earlier, is 1, because it cannot exceed the values of 1 or negative 1. The amplitude, the period, which I'm going to be abbreviating in P, is 2 pi. And what does this mean? It means that the sine function will repeat its graph for every 2 pi rotation, which is in a unit circle for every revolution. So with that out the way, we can start plotting the sine function with this background in mind. Sine of 0 is just 0, which is the origin right here. Pi of 2, sine pi over 2 is equal to 1, which is right here. Sine of pi is equal to 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. Now with that, we can connect the points, which will look something like this. It will be a curve, and it will remain a curve forever. And this right here, this function I've graphed out, is only one, note, it's 1 period of pi, which is 2 pi. So what do you mean by the graph repeating itself? Well, this little segment of the sine function will repeat itself for future revolutions, which if you're going to keep on graphing out from 2 pi from 2 pi to 4 pi, which is something, will be something over here, will look something of the same. So this portion, drawn in red, is the same as the period of 2 pi, the first period, the first revolution of sine of theta, which is the one in black. And this will repeat itself forever and forever, same thing in the negative direction. And from here we have graphed out sine of theta's graph. Moving on to cosine of theta. Cosine of theta is in some ways the kind of the opposite. Like, it kind of looks like the opposite of sine, but it's not. Note, it's not. It's just for somewhat of a visual relationship. And then likewise for sine, we use the exact same special angles that we used previously, which is pi over 2. Oh, that's pretty badly drawn. That should be pi. This should be 3 pi over 2. And this should be 2 pi. With the origin remaining the same, and putting our highest and lowest values of cosine as so, 1 and -1. Like the sine, the greatest value of cosine is 1, and the least possible value of cosine is -1. But unlike sine of 0 is equal to 0, cosine of 0 is equal to 1. So we plot that out right here. And I should probably write, this is cosine theta, like so. And cosine pi over 2 is equal to 0. Cosine of pi is equal to -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. And we graph out this function like so. And likewise, I drew for sine. This is the first period of cosine. This is the first period, which the period of cosine is 2 pi. And the range of cosine is still 1, as the greatest value of cosine is 1. And for every 2 pi rotation, the cosine function will repeat this little segment of its graph. And so if you're going to redraw it out, extend this to 4 pi, it will repeat itself, this function. Now this is poorly drawn, but you get the idea. And it's important to note that this is a very simplified version of drawing the cosine function, as we have skipped out other points within the cosine, which if you keep on graphing it out will be more precise. But for the sake of this video, this will do. So as a recap, the cosine function's graph is periods 2 pi, and the cosine function's range is 1. And the sine function's graph has a period of 2 pi, likewise the cosine, and likewise the cosine again has a range of 1. In the next video, we'll be graphing out the tangent and cotangent graphs, and then following the secant and cosecant. I hope you learned something new.